Okay, what are we doing today? We're doing something called the sine rule. And what the sine rule is going to help us do is it's going to help us solve triangles that are not right angled. So back in grade 10, when we solve for unknown sides and angles, we only have the two. Oh, that's
did you find out
someone.
how to get in?
Oh, there we go. Let me just hit mute all, and then we'll. There we go. Hopefully I haven't muted me. Okay, no, I haven't. All right. And welcome to Amelia, who has also joined us. Okay, so what I was saying is in grade 10, you deal with this thing called SOHCAHTOA, and you use SOHCAHTOA to help you solve for angles and sides using a right angle triangle. Okay, so that is grade 10, but the problem is that is only valid in right angled triangles. What if you get a situation like this where you have to find an angle, but you don't have a right angle in your triangle? Well, you can't use SOHCAHTOA. So you can use something called the sine rule. And what the sine rule does is it says if you take there's two ways of writing it. The one is to write it with the angle on top. So if you say the sine of an angle divided by, so the sine of an angle divided by, so let's get the side opposite is equal to the sine of another angle divided by the side opposite that is equal to the sine of another angle divided by the side opposite that. So that would be this way of writing the sine rule. And then the other way of writing the sine rule is to write it with the sides on top, where you go a side divided by the sine of the angle opposite is equal to another side divided by the sine of an angle opposite that. Sounds like a bit of a mouthful, but let me show you in an example. So say that you want to find what the size of angle y is. I'm going to write the sine of y, and I'm going to divide it by the side opposite, which is 10. And that is going to be equal to the sine of 64 divided by the side opposite that. Now what you have is a trig equation. But what you're really after is this y over here, which is represented there. So what we need to do is we're going to move the 10 to the other side, and we get the sine of y is 10 times the sine of 64 over 15. Give me a thumbs up if you followed that so far. Give me a thumbs down if you didn't follow that. I want to get a feel for how that went for you. Okay. Now, in order to unlock the y, we need to use the inverse sine function. So on this side, so Stephen, hang in there. I'm going to do another example now. In order to undo this, I need to use the inverse sine function, but I need to apply it on both sides. And then I'm going to get, basically what I need to put in my calculator to make this work is shift sine to get inverse, and then I'm going to type 10 sine 64 over 15. So even if we don't understand this yet, I want us to take out our calculators, and we're going to do this together. We're going to go shift sine fraction button 10 times the sine of 64 close brackets over 15. And then you're going to close the big brackets. And in the chat, I want you to tell me what you guys get. What are you guys and girls getting in your calculator? I'll give you a moment to see that. So, young Stephen, or Stephen, Siamtanda, Rulani, Amelia, what are you getting when you put this sequence in your calculator? So the steps are shift sine, open up the fraction, so like hit the fraction button, and then on the top you type 10 or you can 10 sine 64, then close the bracket, then go to the bottom, type 15, and then close the big bracket around everything, then hit equals. And what I get is 36.81 degrees. And what that is telling me, using the sine rule, this is 36.81 degrees. So I've solved for this angle. Now, I could not have done that if I was using SOHCAHTOA, because SOHCAHTOA depends on a right angle being there. Okay, so let's do another example of this just to practice, or we'll do this together. There is no right angle in sight, but the question says find this angle Q. So using this new thing called the sine law, I'm going to write the sine of Q over something. What is that something going to be based on what we've done so far today? So it's going to be the side that is opposite Q, which is here. So that's going to be 8. Now this is going to be equal to the sine of 104 divided by what? So it has to be the 15 because it's opposite that 15. Okay, now we mustn't lose sight of the fact that we need to get this Q. So what is my next step going to be in order to get the Q by itself? What's the next step going to be? Don't worry, Emilio. So let's start again. So we are using a new tool called the sine rule. And what the sine rule says is if there's an angle that you want, you write the sine of that angle, and then you divide by the side opposite that. So in this case, it's 8. But then you need another part of the equation. So you find another angle, and you say, what's the sine of that angle? And then you divide by the side opposite that, which is 15. Let me know if that helped, Amelia. Now, we need to move this 8 on this side to the other side. So I multiply this side by 8, and I multiply this side by 8. And what I'm left with is sine of Q is 8 times sine of 104 over 15. Okay, now, we need to find what this Q is. In order to get Q by itself, we have to apply the inverse sine to the side, and then I'll get Q by itself. And I also need to apply inverse sine to the other side. But inside that bracket is going to be 8 sine 104 over 15. Now, I want you to put this in your calculator and see if you can find what the Q value is. So we go shift, sine, fraction button. 8 on the top of the fraction, 8 sine 104, close the bracket. On the bottom, put 15. Now make the big bracket closed around all the stuff and hit equals. What angle are you getting for Q according to the use of this thing called the sine rule? So Amelia and Rulani have got 31.6, and on my calculator, I also have 31.16. Now, for an extra bonus, I want you to find what is the size of the angle with the red dot. You don't have to use the sine rule. You can use any geometry that you know about. What do you think I could use to help me find the size of the red dot? I remember something about all the angles in a triangle. Yes, Rolani, exactly. So we know that angle R will just be 180 and the reason would be sum. So 180 minus 31.16 minus 104, and I get, let's see if you get the same as me, I get 44.84 for this angle. So this section is all about solving for unknown sides and unknown angles in non-right angle triangles, but using these new laws. And one of the laws you're going to learn is something called the sine law. Give me a score out of 10. So where 10 is perfect understanding, 0 is no understanding, 5 is some understanding, but you want to get better. Okay, so we need to practice this a bit more. So that's fine. Let's do another one. If we look at this example, I want to find angle ABC or just this B up here. So I'm going to start by writing the sine of B. What is going to be below that thing? What is going to be below that if I'm using the sine rule? It has to be the 20, yeah, because that's the side that is opposite. Who feels like they know? I think it's going to be the sine of 60. But what is then going to be below the sine of 60? Oh, Rolani, you brilliant. You've got 18. Okay, now I want you to try and work by yourself to try and get what the angle B is. If you get stuck, I want to encourage you to ask a question, but see if you can figure out what angle B is by yourself, and then put your answer in the chat. So think about what has to be moved around. Think about what has to be done on your calculator in order to get what the sine of this angle is. I'm going to have to use inverse sine of this big fraction. And then I've obviously got to put this in my calculator properly. So let's see if I can do that. I go shift, sine, fraction button, 20 sine 60, close bracket, go to the bottom, 18, go to the outside, close that bracket, press equals, and I am getting 74.21, which I see Amelia and Rulani and Siamtanda agree with me. And I think that is okay. Now, obviously, we need to practice a few more. So let's see if I can get another. Oh, and Stephen agrees as well. Why don't you find me the size of angle X over here in this one? We'll ignore this one for here for now, but let's see, can you do this question all by yourself and figure out what this angle X is? Over to you guys and girls. Ask yourself, what do you think? What do you think goes where? And then once you've got your answer for X, I want you to put it in the chat. What are you getting for X? Okay, let's see what I get. So shift sine fraction button 30 sine 20 close bracket over 60 close big bracket equals, and I get 9.85 if I round off. So X should be 9.85, which seems a bit small, but yeah, whatever, that's fine. Okay, give me a score out of 10 for how you find the angles using the sine rule. Give me a sense of about this process out of 10. Yeah, let's do one more. Let's do one more. Well, let's do a multiple choice question. I love a good multiple choice question. Which of the 4 options here do you think is the correct to find the, yeah, which of the 4 options do you think would be the best way to do this? So we would go sine of y over 7 is equal to the sine of 34 over 8, which would be A. All right, I want you to now work out what is the actual angle y going to be. I want you to work that out for me, please. What is the actual, okay, that you, using the sine rule and using what you know the working out steps are? So we move the 7 to the other side, and we're going to get 7 sine 34 over 8. And then to get y, we're going to go inverse sine of whatever was in here. And Amelia and Rolani and me all get 29.29 degrees if we round off. So that is going to be the angle up here. All right. So when we use the sine rule, we can use the sine rule to find angles. And when we are finding angles, we write the sine at the top. We divide it by the side opposite. And then we find another angle. We go the sine of that angle divided by the side opposite that. Now, after the break, we're going to use the sine rule to find missing sides. And so we're going to write the sine rule out in a slightly different way. But a very quick, not very long, just a quick jumping jack break. That's all we're going to do. So we're going to get away from our table. We're going to just stand up. And this is what I call a jumping jack. And we're just going to do 10. And then maybe I'll add a few more on. Only break we are doing. So 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do 5 more. 1, 2, 3, 4, 5. And that is the reset break that our brains crave between learning. So be a heart emoji if your heart is pumping from the jumping. I think there's a heart emoji somewhere. Where is it? Let's see if I can find it. Can you see my heart emoji? Maybe you can't. All right, there we go. Let's do this, people. Okay, so part 2 of today. If we are all this okay, so the law of sines can be written in 2 ways. The other way of writing it is where the side and then below it is the sine. That angle is equal to another side of the. Now this is actually the easier of the 2, so let me show you why. So if I want to know what this length is here, this length x, using the law of sines, all I need to do is go x divided by sine 115 is equal to, now I need another side, so what's another side that I have? Oh, I have 11, so I go 11 divided by the sine of 48. Now, I only want to figure out what this x is. So the sine of 115 is getting in the way. So you know what I'm going to do? I'm going to multiply both sides by sine 115. I'll multiply this on this side so it's easier to see. This cancels out, and I get x is 11 sine 115 over sine. Put that in your calculators and tell me what you get for the x value. Put that in your calculators and tell me what you get for that x value. Now, there's no inverse sign here. It's just normal sine. So I get fraction button, 11, sine 115, close, then go to the bottom, sine 48 equals. I am getting the length 13.42 units, or centimeters, because the units are centimeters. So the sine rule is actually super easy to use because it's even easier to use when you're finding sides than when you're finding angles. So you write down the side, divide by the sine of the angle opposite equals another side divided by the sine of the angle opposite that. So I want you to do, let me find you one to do by yourself before we do any of this. These are all multiple choice questions. I want, what do we want to do? Work out the length of BC. Okay. Here is the length of a side that I want you to work out. I want you to set up a system using the sine rule, and I'm not going to give you much more help than other to say you need to fill in what you think goes in these. And then I want you to find what that BC is going to be. If you get stuck, you can raise your hand and ask a question. But let's see what we... So I'll start by writing BC over the sine of 33 because it's opposite there. What do you think is going to go in the red block place? What do you think is going to go in the red block? It has to be the other side that you are given. Yeah. So we'll go 15. And then we say, well, what is opposite 15? It's 112. But remember, you must have that. Okay, now what you need to work out for me is what is the length of BC? What are we going to get for that? I think we just have to bring that sine 33 to the other side. Yes, CM Tanda, you can unmute yourself and ask your question. What is your question?
So you can finish for now. I'll ask after.
Okay, cool. So BC equals fraction 15 sine 33 close bracket sine 112 close bracket. And what do we have? I have 8.81 centimeters. Okay, yes. Go ahead and ask a question.
So basically, is it fine if we can also put the angles on top when I'm finding the sides? Because I did that and I got the same answer.
Perfectly fine. So what's being asked is, what if you just stick with doing this, okay, and then you just rearrange it so that BC is by itself? It's completely fine, and you will get the same answer. I just know from experience that it's quicker, or at least it's normally quicker for most students, to start with the thing they want on the top. But if you know what you're doing, it's completely fine, and you'll get exactly the same answer. So
Okay,
great
thank you,
question.
sir.
Pleasure. Okay, let's do some of these fun multiple choice questions. So here is this question. It says, use the law of sines, or using the law of sines, which is of the following is the correct formula for B? So I want you to look at the options and say, which of those four options do you think is the correct expression for b using the law of sines? So I'm just going through my process and I'm getting that, but then this would have to be 5. And then is there an option? It's definitely not that. That looks good. It must be b. Find me what the value of b actually is. Like, what is the length of that side? What is the length of b going to be? So I'm going to put that in my calculator, and I'm going to get fraction button 5 times the sine of 56 over the sine of 80. And I'm getting 4.21 as my units, assuming they are centimeters. Now, I want to do something a bit funky because you guys are getting a little bit too good at this, so I need to challenge you. Okay. I want us to work out this side over here, but there's a problem. What is the problem with working out the length of AB? Who can spot why finding the length of AB is a bit more tricky than the earlier ones? We do not have the angle C. Yeah. The problem we have is we would really like the angle C. Now, who has a way of figuring out what the angle C is going to be using what you know about mathematics and different ideas? Yes, Rolani, perfect. You know these two, therefore you can work out that angle C is what? So 180 minus 80 is 100, minus 56 is 44, and the reason is sum of angles in a triangle. So this is 44. Now, using your new knowledge that you've acquired, I want you to find me the length of AB. Find me the length of AB. What are you getting for the length of AB? So I'm going to go, this is going to be 5 over the sine of 80. I'm just going to use what we had here already. And then I'm going to move the sine of 44 to this side, and I'm going to get the sine of 80. So let's see what I get now. Fraction 5 times sine 44, close bracket, over sine of 80, close bracket, equals, and I'm getting 3.53 centimeters. So this is 3. Okay, now, final question. I want to know, what is the perimeter of triangle ABC? They often ask you, like, what is the perimeter of the shape? And you need to use the sine law to help you. What is the perimeter of ABC? What does the perimeter even mean? It means the distance around the outside of a shape. So all I need to do with this is add up the length of the sides that I've got already. So 5 plus 3.53 plus 4.21 is equal to 5 plus 3.53 plus 4.21. And we have 12.74. And this would be centimeters, is the perimeter of the shape. Nicely done, Silikani and Rulani. Very nicely done. All right, let us keep looking. So let's have a look here. Okay, which of the four, I want you to identify which of these four options is correct for the question. Which of these four options is correct for the question if you're using the sine law? So let's have a look. How would you set this out? You'd go x divided by the sine of 64 is 11 divided by the sine of 104. And for me, that would be B. I feel like you guys are getting this. Like, almost, give me a score out of 10 for how you're feeling about finding sides using the sine rule. Give me a score out of 10. I've done that already. Okay. Let's do this. You do this all by yourself. Find the size of the length x. Find that length there. Practice makes perfect. We just keep practicing and we'll get better. Notice how there's no right angle in the house. So there's none of this stuff. So unfortunately, SOHCAHTOA will not be of help to us, but the sine law will. So x divided by the sine of 46 is equal to 20. Oh, flip. I don't know what this is. Who can help me? What is that going to be? Oh, of course, I just know sum of angles in a triangle. So this is 86. So then I need 14 to get to 100. So this must be 94. So now I know this must be the sine of 94. Then x should be 20 times sine 46 over sine 94. So what are we going to get for x? 20 sine 46 sine 94. And Amelia has got 14.42, so has Rulani. And I'm pretty confident. Well, I get the same thing. So I'm feeling pretty confident. Okay, now I think for the final question today, I want you to find me the length of the green squiggly line. What is the length of the green squiggly line going to be? I'll call it y. What do we think this is going to be for y? I guess I would use the 20 over sine to help. I would. And then 20 times the sine of 40 over the sine of 94. So let's see what I get for that. 20 times the sine of 40, close brackets, over the sine of 94. What are the girls getting for the distance y? Siamtanda, Rolani, you've got 12.89, and you know what? I've got exactly the same thing. So this distance will be 12.89. Okay, so what have we done today? We've looked at how if we have non-right angled triangles and we can't use normal grade 10 trigonometry, or SOHCAHTOA as sometimes we call it, there are other rules that we can use to solve for unknown sides and angles in triangles. And the rule that I showed you today was the sine rule. And the sine rule, you can solve for an angle or you can solve for a side. You just need these matching pairs of angles and sides that are opposite each other. Now, I haven't got into the proof here, but the proof really just takes any non-right angled triangle and says, look, I can split a non-right angled triangle into two right angled triangles. Even if it's acute or if it's obtuse, I can always make a big right angle triangle minus a small one, or I can cut it in two. And so that's where the sine rule is actually coming from. But we didn't spend any time on the proof. What we focused on today was understanding how to use the sine rule. And so I just want you to give me a score out of 10. How well do you understand how to use the sine law or the sine rule?